So 7.2 clause is all about your wind pressure. Okay, parallelly I am showing you over here as well. All right, so now let's switch to the next part. The PD value will be in terms of KD, KA, KC and PZ. Now what is KD? KD is your wind directionality factor. Now again this particular point is mentioned in the 7.2.1 clause, okay, on page number 9. So KD is specified over here. It considers the randomness in the directionality of the wind and recognizing the fact that pressure of the force coefficients are determined from specific wind directions, and it is specified for the buildings, solid signs, open signs, lattice framework and truss towers. So all these, for all these structural configurations which are triangular, square, rectangle or the truss elements, KD factor will be 0.9. okay, it is specifying over here. And for circular or non-circular form, this factor may be taken as 1. okay, so your KD value in case of the truss elements, solid, rectangle or open segments, okay, lattice frameworks, for all these components, this particular KD value will be 0.9. but in case of the circular element, this value will be taken as 1. okay, I have whatever the important points are there, I have highlighted over here. okay, so your KD value will be something like this. And for the cyclone affected regions, the factor KD shall be taken as 1. okay, cyclone affected regions means all the structural configurations which are located, or the area which are located near the sea area. okay, so for that particular, your KD value will be 1. otherwise for the nominal structural configuration, you can take KD value as 0.9. okay, now the next part, KA. Now KA is the area averaging factor. So here pressure coefficients Ka value is explained in your clause 7.2.2. now what is this area averaging factor? So here code has given a particular table in terms of your tributary area, and based on that your area averaging factor is worked out. Now see, 3 categories are given. First is the tributary area less than 10 meter square, second one is for 25 meter square, and third one is greater than 100 meter square. So based on this, you have to work out your your area averaging factor in terms of 1.9 or 0.8. okay, now how will you work out a tributary area? To just make you understand, here I have considered a sample frame. okay, let's say we have a truss configuration something like this, where we have a bay width as a 5 meter and it has a height of 10 meter. okay, so what will be the my area? Tributary area. Tributary area means area on which our load will distributed. okay, so if I consider my tributary part for the column, as you know, if we are implementing the pressure, the half of the loading will be taken from, let's say this is my tributary area. Let me just try it again. See, if I apply pressure in terms of meter square, okay, so it can be a two-way action or a one-way action depending upon the configuration. Like it is the similar way, the way we distribute our slab load, either it will go in terms of one way or two-way, right? So if I assume something like this, this particular will be my tributary area, right? So basically for 5 meter span, whatever the wind is implementing over here, half of the loading will be gone in this particular column, okay, and half load will be from this particular side. So ultimately for 5 meter and 5 meter part, if I consider 2.5 as a half part, okay, the load distribution will be here in this region, right? So that will be my tributary area. Okay, so let's say for a wall part 5 meter and 5 meter, so I am considering 2.5 from here and again 2.5 from here, so this particular length will be 5 meter and my height is 10 meter, so 5 into 10, 15 meter square. Now this particular will falls under the category between 25 and 100, so my area averaging factor K will be 0.9. Okay, now there is a note written over here. If you want to go for the interpolation for the accurate results, you can do this, right? So 5 into 10 will be my area averaging factor. Now one thing to remember over here, right now I have just give you the idea about this wall part. Similarly you can have a different structural configuration, so for roof part as well the tributary area will remain same. This will be my tributary area, right? So you can work out. Now let's say I'm getting the area of 12 mm square. Let's say my width is 6, bay width is let's say 3 meter. Okay, 3 meter bay width, 3 meter, 3 meter instead of 5. Okay, so 3 meter is this, and let's say we have a height of let's say 8 meter. Okay, so 3 into 8, 8 3s are 24. Okay, so again it is falling under this particular category. If you have the lesser area, now see in some of the configuration what will be the situation. Let's say you have a wall up to 3 meter height, then you have roof sheeting. This particular situation can be occurred, so in that case your wall area will be up to here only. Okay, let's say this is 2 meter. Okay, and you have a bay width of let's say 3 meter, so in that case 3 into 2, 6 meter, so it will fall under the category of first one, less than 10 meter square. So you will get area averaging factor as 1. I hope you are getting this point what I am trying to convey. Okay, in some of the PEB shades you have the requirement let's say 3 meter, you have RCC columns and walls, and from above height, okay, let's say you have a AV height as a 5 meter, but in that case up to 3 meter you have wall, and your PB component is starting from 2 meter, and then you have start shade, something like this. So in that case let's say this is my bay width 3 meter, so 3 into 2, okay, it will a wall as something like this. This is my height 2 meter, this is 3. Okay, because there is not much impact on your RCC column, so your wind for this particular steel frame will be in terms of your 2 meter height, and 3 is let's say my bay width, so 3 into 2, 6 meter square is the area, so it will fall less than in this category, less than 10 meter square, so your K will be 1. Okay, so that's how you can work out your area averaging factor. Okay, if you want to interpolate you can go for the accurate results. Let me just erase this. Any yes, any confusion?
Yes, sir. But in stand model, we do model the steel column up to the total height. So when we apply the load, it will be applying throughout the height. So, but you consider that there will be 3 meters of RCC wall, but we don't we don't model the RCC wall. We still model the
yeah, we will yes, we will only model steel column, but I am talking about the consideration part, means in you don't have to consider the full height. Let's say as you mentioned, let's say this is the 3 meter high, let's say this is 3 meter and from 2 meter here, so yes, we will model instead up to here only, but for considering the Ka value don't consider the full height. That's what my concern is. Are you getting my point?
okay, okay, sir.
Yeah, see this is 3, this is 2, so if you go for the configuration part for the wind implementation, this particular part is only that will gonna impact your wind, not this one. So while calculating the Ka factor, don't consider the full height for this particular wall load, because it will impact on your coefficients value and you will get a higher coefficient if you consider full height of 5 meter.
Sir, I have a doubt.
Yes.
Sometimes we have PEB from means from plinth level and wall is outside the shade. then in that case, what height we should consider for?
I don't understand that particular situation. Will you repeat
The wall
again?
is outside the PEB column,
Okay, wall is
and PEB
outside the
column
P.
is from,
Inside.
yes.
Okay, now again that will depends on the condition how they have considered, means your PEB segment is starting from the bottom level or from the 3 meter part. Now again, if you are modeling for a full height, let's say you have a 10 meter height of full steel column, but if they have considered up to 3 meter the wall part, right? But for steel frame you have to consider a full height. If you
Okay,
have
sir.
if you have RCC column up to 3 meter and then your steel frame is starting, then you have to go with that much height, because for RCC column wind will not have much impact. Okay, in the analysis part, let's say whatever the section you are designing in StatPro for the PEB design part, that much component you have to for that much component you have to implement your wind load. Okay, so while calculating this Ka value, you just keep this in mind. Okay, so any doubt for any other doubt in Ka value?
No, sir.
Okay. Okay, so we have gone through the KD value. Now we will move further for the KC part. Now let's understand what is KC. Okay, I just have to. Alright, now see, for the KC value on page 16, the clause 7.3.313 is mentioned. Let me just take you to that particular clause. Yeah, it's 2015. What was the page number 16? Okay, now see, for KC value, there is a clause specified over here. When taking the combined effect of wind loads on the frame, a reduction factor of KC 0.9 may be used over the building's envelope when the roof is subjected to pressure and internal suction, or vice versa. When taking the wind loads on frames of clad buildings, it is reasonable to assume that the pressure or suction inside and outside the structure shall not be fully correlated. Okay, either you can have the pressure part or the suction part. So in most of the pre-engineering building structure where we have roof sheeting, right, you have this segment of pressure and suction. So that's the reduction factor specified over here in terms of KC. Okay, it is specified as 0.9. There is no further clarification for the KC value in the code. It is just a reduction factor. Okay, so we need to incorporate that particular value, that is the KC value, in terms of 0.9. Okay, so we have gone through the KD part, Ka part, KC, and then we have PZ. Now again PZ is 0.6 VZ square. Okay, and VZ will be what? VZ will be in terms of your K1, K2, K3. Let me just alright, so again PZ is the easiest part that you have already gone through your P level as well. PD design wind pressure we need to work out now.
So we know that, so we can go
Ahead. Yeah, just I'm
Yeah.
there is one part left. Okay, yeah, see this point which is in terms of what we can say the KD value. Okay, and in that point I have explained all the part that for the regular structural frameworks, truss towers and all this part, you have to go with the 0.9 part. for a circular and non-circular forms, this factor can be taken as 1. Now again there is one point mention that for the cyclonic affected regions KD shall be taken as 1. Okay, so in the map the specification of the cyclonic region is considered in this particular part, the bottom part, which is nearer to our coastal area. Okay, so that particular part in the southeast region, that particular part is considered as an cyclonic affected region. So up to few kilometers, that particular, if your structure is located in this nearby cyclonic region or the cyclonic affected area, you have to take that value as 1. Okay, there is one another note. If I find that, I'll mention in the next class. Right now I'm not able to find it, but yeah, we will discuss that. So that was one another point. Yeah, it is mentioned here in terms of K4. Yes, okay, yeah, so that is in the K4 part. All right, just a moment. Okay, now see, for the calculation of the Vz, we have this equation Vb, K1, K2, K3 and K4. So all of you are aware with this K1, K2, K3 part. Now K4 is the importance factor. That's what I'm talking about. Okay, that is the importance factor for the cyclonic region, and there is a note written in your code here. This one, the east coast of India is relatively more vulnerable for the occurrences of severe cyclones, and on the west coast Gujarat is vulnerable for the severe cyclones. Okay, study of wind speed and damage to the buildings and structural point of the fact the effect of cyclonic storm is largely felt in a belt of approximately 60 km width at the coast, and in order to ensure a better safety of the structure in this particular region, up to 60 km wide on the east coast as well as on the Gujarat coast, the following value of K4 is recommended. Okay, so if for all other structures the K4 value will be 1, for industrial structure your value will be 1.15, but if your structure is located in the cyclonic region, okay, up to 60 km, so what does it mean? For that particular cyclonic region part, your K4 value will be higher side, that is 1.3. So the region that they are talking is basically this one, from here to here. Let me just so in this part they are considering the region from your edge to the 60 km till Gujarat. Okay, so from your cyclonic edge up to 60 km, this will be your cyclonic region. Okay, so in that area, if your structure is located in that area, you have to consider K4 value as 1.5. Okay, east coast and the Gujarat region. So that's the important point about K4. That was the main important part over here. Okay, so that is the indication. All of you are aware with this category and all that part, so I'm just give you a brief that based on your category of 5 to 10 meter, 10 to 15 meter and greater than that, your K1, K2, K3 value will be worked out. Okay, so this, from this particular clause you can refer this, and if you have any doubts you can tell me. Now let's go for this. Yes, then there is one another important note. Now see, clause that 7.3.2.1 specifies the internal pressure coefficient, right? The external pressure coefficients we will get to know about from this table of 5 and 6, right? From table 5 and 6 we will work out from here, table 5 and the table 6. Okay, this one is for your walls and this one is for your roof part. Okay, so that is, you can work out from the tables. Now for internal pressure coefficient, code is specifying that if your structure has openings limited to up to 5%, okay, then your internal pressure coefficient will be in terms of 0.2. Now there are three categories: 0.2, 0.5 and 0.7. So the major area which is important, that is I have already highlighted over here. Okay, so up to 5% if you have opening in terms of your, if you have windows, or if you have the rolling shutters or the movable part segments. Okay, so in terms of windows, generally in PE we shade you, if you have windows, okay, if you have up to 3-meter wall segments, then you might have windows for the ventilation purpose, and that particular opening, then you have to calculate it separately. If that particular opening is up to 5 meter square, okay, 5% opening, sorry, 5% opening of your total structural configuration area, then you have to consider CPI as plus 0.2, plus or minus 0.2. If it is between 5 to 20%, then your coefficient will be plus or minus 0.5, and if it is more than that, then you have to consider the coefficient in terms of plus or minus 0.7. Okay, so that is the another important part. Now see, your structural configuration will be analyzed for each particular direction in code. Okay, let's say now when you work out your wind pressure for the 0 degree as well as for the 90 degree, you have to work out your CP value, that is internal pressure coefficient and external pressure coefficient. Okay, so you have to work out in two categories. Let's say you are considering your wind from the 0 direction, so in that direction you have to go with plus 0.5 CPI value. This is your CPI value, and this will be negative. Okay, so when you are analyzing your structure for the wind, you have to go first with the plus point CPI, then you have to go with the minus point CPI for 0 degree. Similarly, when you go with the 90 degree part, okay, in that case also you have to go with first plus 0.5 CPI, that is for the positive value and for the negative value. So we will go with the first plus 0.5, means we are assuming suction, and then pressure. Positive means pressure, so we will analyze our structure with CPE plus or minus CPI. Okay, so once you have to assume pressure, then you have to assume suction. So for each category you have to go with plus 0.5 and minus 0.5. Okay, so for each direction, that topographical understanding of the graph is specified over here. So first you assume pressure inside, then you are assuming negative inside. Similarly, for all the cases you have to work out. Now while calculating the wind, we will understand that particular part in the further session, and how you can go for it. Now